My group mates is Quadru, Lu, and Ong will be presenting to you sustainable technologies that may be applied to our current project, the bus stop terminal. So next slide, please. So here is an overview of the sustainable technologies that we'll be covering: storm-resistant design, bioclimatic strategies, adaptive lighting designs, double-skin facades, solar panels, rain garden systems, smart glass, and finally LED lights. Next slide. So first we'll be discussing about the storm-resistant design as it is very much relevant ever since the last typhoon experience where it destroyed lightweighted terminals. So storm-resistant design has four factors which would affect the overall structure and durability of the designs, and that is the roof structure. We have to study the wind flow, application of fenestration, and the type of fenestration we have to use. Next slide, please. So first we will go to each factor as it has causal relationship to each other. So for example, that the wind flow will help us know what kind of wind or fenestration to apply and what right roof structure that will lessen the wind pressure inside. So here are the first with the general guidelines is the windows should be at least opposite of each other. So this will have at least an exit or an entrance of the wind directly from each other or indirectly from each other, as it will lessen the wind pressure that is inside the structure, or it will or it will at least have an output and input of wind flow inside the structure. So it doesn't have to be actually equally or rationally across each other, or at the same time it doesn't have to be directly across each other. So opposing windows don't have to be in equal width or height, but can be divided or merged as long as it can cover possible airflow input. You'll see what I mean later. I have an example. So think downwards, where the wind direction towards the it should be towards the floor for effective cooling to the users. One helping tool of this would be the wind louvers or any types of window fenestration that can manipulate the wind flow inside the uh, building. So next is to avoid tight and narrow space airflow, as narrow spaces will compress the airflow and heightens air pressure and the velocity, which would again destroy the space from inside out. Next slide. So now that we covered the guidelines, let us look into examples on how to utilize better safe ventilation airflow that will be at least storm durable. So here in the first diagram is that don't and do in an airflow through the floor plan view to see the wind coverage without actually having the wind pressure destroying the whole thing or the structure. So first don't is to have the tight narrow windows opposing from each other directly. So this is what I meant with it doesn't have to be actually opposite from each other, and at the same time the one thing you should at least take note of is that the tight or the window size should, if it's small, you should at least distribute it across the room rather than having one tight window across each other in one room. And next is the meaningless corner windows. And once again, there isn't even any airflow of the majority of the interior. The third diagram is the first, but with more windows. More windows does not make it efficient for the wind coverage and only adds more wind pressure inside as it when is inputted. So if we're going to add more windows, at least make the neighboring window much more bigger than the other one. Next is the corner window with the room or the or obstruction. It will not even reach half of the room or the opposing window. So our reduce is that we have we have here is the about better coverage for the wind floors, indirect windows but opposing walls, better ratioed windows, and windows are not covered. Hello, yes, sir.
Yes, you don't have to explain all of the each
Okay,
diagram. We can
okay, sir. And
get the idea
yes,
already.
okay. So here is the diagrams. And let's proceed na lang. So next is the roof structure on how the typhoon could actually affect it exteriorly. So of course there we have a diagram. So the wind pushes the building over. What's important is that the wind shouldn't suck the building over. So we have some few methodology to combat that problem. Next slide, please. So here are some tips on the roof structure that avoids tipping the structure or the roof over. As A is to have a smaller eave, 45 cm max, but is long enough to protect the walls from the rain. And B is to have the roof slope should be at least 30 degrees, and it would be redirecting the wind upwards rather than over the structure, but not too steep like 50 degrees, which would tip the roof instead, as it is enough for the wind to push a flat surface rather than rolling it over like the 30 degrees roof. The roof shape, also the strongest to counter the wind, is the hip roof, since it has more slopes for the wind to be redirected rather than your roof being pulled apart in a one-sided manner. So next we have can you next slide, please. So we have a climactic designs where we'll be discuss the natural cooling, evaporative cooling, and solar protection. This is very applicable if you want to formulate your this design strategy on the economic and passive design side. Next, please. So by climatic design is formulated to to aim or serve users with comfortable and aesthetics renewable sources as method of ventilation and lighting. Next, please. So first we have the evaporative cooling strategies. I already have the diagrams there. You can take a screenshot if it's very relevant to your design. One suggestion of the evaporative cooling is to use the greenery or the existing trees or existing greeneries in the site or at the same or make an atrium in each of your structure. Next slide, please. So next is the solar protection. Here is another one. Another wise economic way would be using again the trees existing and eaves and also canopies or maybe a double skin facade in your architectural uh for, for architectural aesthetics and protection. Next slide. Natural ventilation. There are very many ways to do natural ventilation. As you can be creative about it. We have what do you call this? We have ventilation or sky shafts or airflow shafts. We also have windows that could actually let airflow within and out. It could also be the double window double glass windows that could also let airflow from the bottom to the outside. Next slide, please. Okay, we'll be passing it to Shara.
So, good morning. Good morning, everyone. I'll be discussing about the adaptive lighting systems, its overview, operation, and pros and cons. Next slide, please. So, adaptive lighting systems are defined as a sensor driven network of smart bulbs that are capable of observing and interpreting changes in the environment in order to dynamically alter its operation. So, this can give users optimal comfort and actually lower the electricity costs, making the bus terminal energy efficient. So, you can also apply this in the plate. And the main advantage of smart lighting systems is that it's very cost effective. The design of these smart lighting control systems aims to provide required illumination conditions with low energy consumption. Next slide, please. So, adaptive lighting systems use occupancy sensing, and this is a lighting control method that allows lights to turn on or off automatically depending on the occupancy of a given space for a certain period of time. The mechanism of occupancy sensing is synonymous to the wired and wireless lighting control systems. So, when movement is detected, the lights are turned back on or off to the chosen level. And movement detection is aided by motion sensors that use infrared, ultrasonic, or microwave sensing technology. Next slide, please. So, as you can see in the picture, when a person goes under the light, it turns on, and then it's like the light can sense like when a person is going near it as well. So the number of sensors that should be installed in a given space in order to provide appropriate input to the lighting system is determined by the size and kind of space, as well as the desired lighting performance. As long as an occupant is present in the field of view of any of the wall mounted sensors, a simple scenario entails all bulbs working synchronously and giving an identical level of light intensity over the whole space. And next slide, please. So, an advantage of having this technology is that wireless occupancy sensors can be installed easily in the entire building. without having to demolish or break parts of walls to hide wires. In a bus terminal, where artificial light usage may be intensive or even constant, using smart technology like this will be useful in reducing energy costs, promoting inclusivity and accessibility, especially to people with disabilities, and it can also create a more climate sensitive and comfortable environment for the users. However, it has some advantages as well because some lights may malfunction, like it might be triggered falsely. And then you also need to consider the proper placement of sensors so that the lighting systems can work properly. And sometimes the upfront costs or the initial costs are much higher than you'd expect it to be. Next slide, please. So now I'll be discussing double skin facades. So this one is actually a bioclimatic technology as well. And I'll be discussing its overview, operation, and pros and cons as well. Next slide, please. So double skin facades or DSFs are facade systems composed of two glass layers that have an intermediate cavity. So these cavities are around 10 centimeters to 2 meters wide where air can flow through it. The cavity functions as a barrier against high temperatures as well as wind and noise, boosting the building's thermal efficiency. So DSFs are a form of active facade due to its usage of equipment such as thermal sensors and fans. And passive design strategies like natural ventilation, daylighting, and solar energy are also integrated in DSFs, making it a hybrid technology since it uses mechanical energy as well. Next slide, please. So as you can see, the double skin facade has layers, and they usually comprise, and these layers are namely the external glazing, intermediate gap, and the inner wall. So the outer layer is usually made of tempered or laminated safety glass, and it protects the building from elements while also permitting natural ventilation. And the innermost glazing protects against heat gain. Like for our country, it protects against heat gain while still allowing natural ventilation through operable mechanisms. So low emittance coatings can be used to decrease the heat gain. So the outer layer, it's usually low E it's usually low E glass that they use for it. And then in the intermediate cavity, air is pulled in. As you can see in the picture, air is pulled in, and then it flows through it by either natural or mechanically driven means. So examples of natural or mechanically driven means are like wind pressure, thermal buoyancy, fan assisted, and automated uh, means like by computer systems. And then in most cases, either manually or automatically controlled shading devices are housed within the cavity, which saves on maintenance costs and allows for diffuse daylight. So these shading devices can be like louvers, or yeah, it can be louvers, and it will be shown properly shown properly in the next slide. Next slide, please. So this is how the double skin facade looks like when you break it down. So it has so the first one is the exterior glazing. This one's like the low E, the glass, and then the the number two is the interior glazing. So this is where the people are like. So this is what the people inside the building can see, and then the third is the structural frame, which holds the two glazings together, and then number eight is the maintenance catwalk. So of course you also have to maintain this glass. So the maintenance people should be able to walk through it or like clean it and make sure that it's working fine. And then number four is an example of a shading element. So this one's like the operable sunshade. Ah, yes, good. Yes, sir.
Yes, Sierra, just wondering, so people can walk on that maintenance catwalk?
Yes, sir.
So this thing
But
is really big. May makasudo sa katao diha.
yes, sir, because the intermediate cavity can be around, I mean, can be up to 2 meters based on based on my research. So yeah, it's quite bulky. Yeah.
Mm, okay. I'm just worried about the practicality of it. It's really big, so it will like become
Yes,
really
sir.
expensive.
And then the fifth is the sunshade canopy. So usually double skin facades have uh, wide canopies. And then six is the low operable ventilation. So this is like where the mechanical equipment like uh, is housed in. So that's like where it can help the airflow in the intermediate cavity. And then the seventh is the upper operable ventilation. So you can open those windows there. Okay, next slide, please. So this is the mechanism of double skin facades in tropical climates. So in tropical regions, the intermediate cap can be vented outside the building to reduce the cooling load and offset solar gain. So the chimney effect or stack effect is a process where air density variations generate a circular motion that forces warmer air to depart, and it also drains excess heat. So a modest breeze is brought in from the outside while a small amount of heat is trapped inside the cavity as its temperature rises. So this can be used to reduce air conditioning usage and lessen heat gains in the warmer regions of the site for the proposed bus terminal. And double skin facades are bioclimatic technologies, is what I mentioned a while ago, and it's also used in many buildings, such as the Gherkin in London, which was designed by Norman Foster. And this technology mainly relies on external factors such as solar radiation and external temperature that directly impact internal comfort and quality of life of end users. So, when making double skin facades, you should be able to deeply comprehend the site context, local radiation, thermal conditions, solar orientation, and other aspects of the design process so that these double skin facades can work well and function at its best. Yes. Next slide, please. So these are the advantages and disadvantages of having double skin facades. As you can see, the advantages outweigh its disadvantages. It's nice because it has a transparent facade. It can give like a seamless look, and it's also cost effective, and it offers auditory and thermal comfort. It increases energy efficiency and maximizes views and natural lighting, and it provides better thermal and acoustic insulation. It lowers cooling and heating demands, and it can also create a healthier environment by allowing natural ventilation and air renewal. And it has Windows specific technologies. Yes. I mean, no, sorry. And Windows specific technologies can be eliminated in certain cases. So, the disadvantages of having double skin facades is that it's very expensive. Like its upfront costs are expensive and it consumes a lot of space, like what like your concern a while ago, sir. Yes, and it can demand a lot of maintenance and it may not work efficiently if it's not built in the right manner or if you don't consider the site context properly. Yes, thank you. That's all for my part. So for the next part, it's the solar panels, which will be discussed by James Esquadra.
Good morning, everyone. I'll be discussing solar panels. Now, solar panels are sustainable technologies where it is able to harness energy from the sun, which converts it into electricity, which powers the different parts in the structure. So, solar panels, also known as photovoltaic PV panels, or photovoltaic meaning or PV in short panels. This can be used for a wide variety of applications, including remote power system for cabins, telecommunications equipment, remote sensing, and of course, for the production of electricity by residential and commercial solar electric systems. Uh, some fun fact only. Photovoltaic effect was discovered by Edmund Becquerel. With Becquerel's discovery, Charles Fritz made the first genuine solar cell, which was formed by coating sheets of selenium with thin layer of gold. So these are the layers of a solar panel. First is the aluminum frame. The aluminum frame is responsible in both protecting the edge of the lamination section housing the cells and also gives it a solid structure to mount the panel in position. So this aluminum frame is important for the solar panels to be carried in like a one solid object, just like a picture frame. The next is the tempered glass. Front glass protects the PV cells from the weather and impact from hail or airborne debris. Basically, it is a protective layer from external force. The glass is typically high strength tempered glass, which is 3 to 4 millimeter thick and is designed to resist mechanical loads and extreme temperature changes. So, especially if it's placed on the top of the roofs, which with high intense heat. So this tempered glass can able to withstand those. Next is the encapsulant encapsulant EVA. EVA stands for ethylene vinyl acetate, which is specially designed polymer, highly transparent plastic layer used to encapsulate the cells and hold them in position during manufacture. And the solar cells, I'll discuss in the next slide. And the back sheet is the rearmost layer of common solar panels, which acts as a moisture barrier and final external skin to provide both mechanical protection and electrical insulation. The back sheet, uh, uh, the, uh, the junction box is a small waterproof enclosure located on the rear side of the panel, where the wires and the connection is placed. I won't read the whole thing just to show you guys lang. So this is a close-up view of a solar panel. So solar photovoltaic cells or PV cells convert sunlight directly into DC electrical energy. The performance of a solar panel is determined by its cell type and characteristics of the silicon used, with the two main types being monocrystalline and polycrystalline silicon. So in the bottom, you'll see like different kinds of solar panels, but these solar panels still works the same as each and every one of them. So next is the process. So as you can see in the like a section of the solar panel, you'll see the toughened glass, which basically is the front glass, the front glass. Then there's another layer, which is the anti-reflective coating, which can prevent sunlight from escaping or bouncing off. Next is the front electrical contacts, where the electricity is able to connect. Then there we have the PN junction, the N type, and the P type silicon, which acts as the negative and positive to to flow the to creates the flow of electricity towards the metallic electrical backplates and the front electrical contacts. So for the whole process, so it starts from the solar panel, then it goes to the charger controller, then from the charger controller, then go down to the battery, so it's able to uh, disconnect and connect from the charging and from the battery. Then before the charger connects to the house, it does not. connect directly to the house because it's still DC. So it needs an inverter to change it into AC for it to be useful to be used in the AC in the house because the house is AC. So advantages of a solar panel is that it is renewable energy. It harnesses energy from the sun, reduces electricity bills, so which means it does not get any energy anymore from the power grids. Diverse applications, which I mentioned at the start of the slide at the start of my reporting. Technology development, which means that the technology is constantly advancing, where it still has more room to improve. So in terms of efficiency, productivity, or more advancement on technology, and also low maintenance costs. But for the initial cost, disadvantages, the initial cost really is quite expensive. I have a solar panel in my house, so yeah, it is really got quite expensive. Uh, Next is consume more space. It if we are talking about if it's placed in a uh, yes sir.
Yes, nas po kayo kay solar panels inyo day. How much is
Yes
the
sir.
kilowatt hour inyo ang setup ninyo?
Uh, the solar panel we have is, I think, I forgot, sir, I think it's 300, I think.
Usually,
300.
ang kilowatt hour is, for example, I have my electric. I was gonna talk about solar panels. So we have our like Veco bill here. So let's see here. Asa to siya? The total system charge, generation charge. So usually, solar panel is about like 4 to 5 kilowatt hour ang setup per month.
All
Like
the
the
hours. Oh,
usage is per month ba?
sorry.
So it's kilowatt per hour per month. We usually have around like six. Currently here we have 6.9. Ang general, what do you call this? Like average per month. And then because we installed the solar panels, our what do you call this? Our current usage now is only what is it? Universal charge for 0.07 kilowatt hours, and then consumes more space, weather dependent technology. Not really so much. I just want to highlight this to everyone because I use solar panels. Let me turn off my visual effects so you can see this bill. Okay. So, uh, so you guys can see that this is March 2021. You see the bar going up. That's our like kilowatt hour usage. So that's almost like let's see, what's this? Yeah, per month that's about, if you can see, 600. No, not even 600. Averaging about 800 kilowatt hours per month. And then when we installed the solar panels in October, makita ra ang O sa 2021. It's mirrored manggod, pero it's like this one here. Sorry. Eh, just want to show you na muna ang O diha. And then by March, it's like less than 100 na. I know that's 100 over here. It's still about 100. And then we had, what's that? Sorry, October, November. Sorry, I couldn't like read it. It looked like an M to me. So October, November, December. And then we had no electricity in January because of a debt. And then like when electricity came back in February, our kilowatt hour per month was still like about like just over like 100. And then currently March it's below 100. So it's currently let's see here. Oh no, that's it. That's not 100. It's actually 200. So this line here, that's 200. So now it's well below 200. So it's currently our total payment for VECO is, let's see here. Generation charge is 6.9 kilowatt hours for, what do you call this? I think this is the whole month from, let's see here. Uh, Date 3/18. So that's March 18. So from March 3, last payment was March 3 to March 18. Due date is like April 6. So I'll just show you the cost there. That's 500 pesos per month for this month. Ang kuan, kurente. So sa inyo ha, James, pila man inyong kanang electric bill for this month?
It's, my parents didn't show it to me.
Okay, I just asked them. Anyway, I just want to highlight to everyone that the only sort of problem with solar panels for me is really the initial cost. The
Yes,
space
sir.
isn't even an issue because it's going to be put on the roof. The
Oh,
batteries, mm,
I was talking about like for example roof decks, sir. Like if it's a needed, like if the roof deck is used for if the roof deck is used for like activities, so it may use a lot of space.
yeah, but like how often do you go to a roof
Yes,
deck?
yes, yes. Just examples, sir.
And then the weather dependent technology is really an advantage for us in the Philippines because we're almost always sunny. Even if it's raining, it's still sunny. So this is more, just want to highlight the advantages Jude, of solar panels. Okay.
Yes, sir.
Yeah, sorry for taking your time.
It's fine, sir. That's basically it for my presentation, sir.
Okay, good.
Good day, everyone. So we'll be talking about the other systems and materials that we can apply in designing our proposed terminal. So first is the rain garden system. Next slide, please. The rain garden will mostly be part of improving our landscaping, which is one of the important elements in our design. So the rain garden system is a system where there is a vegetated area utilizing rainfall and stormwater irrigation. These gardens usually filter 1 inch of rainfall in a matter of 4 hours, depending on the size. And it is also a systematic and cost effective way of reducing runoff in a property. The rain garden system provides aesthetic properties in terms of landscaping and at the same time has an important function in design. Next slide, please. Its elements and how it works. So rain gardens also refer to detention basins, but the difference is the rain gardens don't have to be as deep as some of these detention basins, and mostly uses vegetative properties which supports the system. As we can see in this picture, there are certain layers which makes a rain garden different from typical grass or garden. So first is the rain garden media mix. So usually this part of the soil has components that are the ones responsible for filtering pollutants. Next is the ponding area, where a said will hold water until it is absorbed by the roots or delivered into the drainage system, or there's like a kanang rainwater storage. Some I forgot to put it there. It's on the right right side, and then next is the ponding area where oh wait the plants, which is self-explanatory, the mulch layer, which help keeps the soil moist, entry and overflow system, the ones that keep the water from running down, edge supports, drainage and filters and transition layers for both transportation of the water to the collection systems. Now, what I said a while ago, the rainwater storage, under drain system for water filter collection, and the rain garden base. Next slide, please. So for advantages and disadvantages. For advantages, stormwater management, where through the rain garden system, it can filter or soak up 30% more water than typical grass, prevents or at least mitigate flooding, and diverts pollutants for a cleaner water supply. improving health and vivid outdoor space. They also act as gardens, but with a more functional purpose. Similar to gardens, these elements reduce stress, improve productivity, and health. Next is flexible on plant choices. So these green gardens allow a variety of plants such as perennials, shrubs, grass, and trees that are native to the local area and can thrive on moist soil. For disadvantages, it attracts pests. These are only a disadvantage of the system if the system is not maintained regularly, and drainage maintenance. It has to be checked regularly, especially if you pick plants that are of high maintenance. Next slide, please. So next is the electrochromic smart glass, which focuses on energy efficiency. Technologies regarding the improvement of glass is given little notice with regards to advancements, yet smart glass has contributed a lot with regards to sustainability. Next slide, please. This type of glass is one of the improving active glass implemented in the future technologies of green and sustainable design. Also known as smart glass or dynamic glass, these are glasses that are tintable, which are for window facades and curtain walls. Next slide, please. So, how smart glass works. So, smart glass is inspired by double glazed windows, yet utilizes tiny electric signals that slightly charge windows to change the amount of solar radiation which can enter the building, affecting the room temperature. With the strategic use of the glass, it helps reduce the reliance of building in terms of artificial lighting and ventilation. The main purpose of these windows is to control the light and reduce solar heat gain coefficient or heat build-up rays as of the sun as seen in the figure on the side and save a lot on ventilating and air conditioning costs. Next slide, please. So for advantages, it is flexible in terms of shape, sizes, and colors, which supports design preferences. Um, it improves user experience in terms of natural lighting and ventilation and blocks ultraviolet rays and controls the and reduce the solar heat gain coefficient or heat buildup from the sun as said in the previous slide. Its disadvantages are it costs a lot on construction costs compared to regular tinted glass, and it also relies on electricity. Yet its energy consumption has a ratio of 2,000 square feet is to a 60 watt light bulb, like on how much electricity required to power up these windows. Like that's the kind of ratio. Uh, it is also difficult to install with the requirement of a worker or installer that is knowledgeable to install these, which considers both electric and window installation. And lastly, is it's on its availability. Not everyone is knowledgeable about the advancement of smart glass, and it is also not widely used not in every city. Uh, Next slide, please. So lastly, LED lights or light emitting diode lights. This can be a material that can be used on adaptive light systems as reported by Ciara a while ago. Next slide, please. So, for general definition, these bulbs are used to illuminate a place in a form of bulb and fixtures. These offer unique design possibilities. Uh, these provide significant opportunities for innovations in a far wider range of applications. In terms of sustainability and efficiency, it helps the environment as 95% of energy is converted into light and 5% is wasted on heat, making it 80% more efficient than fluorescent and incandescent lights. Next slide, please. So its advantages is more on the sustainable properties where it reduces wastes because of its durability compared to other types of lights. It's also low heat. Its low heat also released to the area, and it poses less fire hazards. And lastly, it has safe components made which protects the environment. Its disadvantages is concerned on the quality aspects such as lumen depreciation, wherein the brightness dims slowly over time. It has potential color shifts and overheating which both affects lamp life. Next slide, please. So these are our resources. Thank you very much for listening.
Okay, before you go, let's go back to the Venn diagrams. Just a quick question to Colleen. Where did you get okay, next slide. Next slide. Oh, oh, this one. Oh, next slide 8. There. Colleen, are you there?
Yes, sir.
Yes. Where did you get this images from?
I have
Like,
a PDF of it, sir. You want me to send the link
sige,
here?
paliw niya send. Because I
Yes, sir.
think this isn't applicable in a tropical setting, especially
Actually,
the
kan
45.
sir, gikan ni sa Philippines, sir. Na
Ano ba?
uncovered. Yeah.
You know?
Wait lang. Ang gipangita.
Because the 45 cm na eaves might not work, where I'm like modeling it on my end. Anyway, I'll show you my screen. So
Okay.
please send me that.
Yeah.
So what
Ang
I'm
kuan
worried,
sa ang explanation dito na sir kay what you call this it's better to use the double facade. So one like outside for mer canopy siya na facade sir for that kind of
hmm,
roofing daw. Or ano and
okay.
entrance.
So mag-double facade instead of using the eaves.
Yeah.
Could be like if makita no source, because I'm already modeling it here. So in SketchUp, if you guys are familiar, I think we'll do like a quick SketchUp workshop. Really good for like quick analysis. Raise your hands if you know SketchUp in the group. Okay, let's see how many. Sir Ruel. Wala. Let's see here. Escardo, Natalie, and Colleen know SketchUp. The rest, let me go on. The rest wala. Okay, so probably we'll do that maybe like next week before the what they call this Holy Week, because I think how many were familiar with like for me like my experience the window height should be about zero point 0.9 meters from the floor level, and typically the windows are about, I'll look at my windows as well, get my Metro Sun. Typically the window should be about 1.2. I think I'm following that here in my house. I'm gonna get 1.2 on. My windows are taller than 1.2. Oh, it's exactly 1.2. So if you can have like a steel tape, you can measure your windows as well. And then from the top of the ceiling to the at the bottom of the ceiling to the top of the window should be around zero point 0.6. You can like stand up from your chairs and like check if this is what your room is like. So just a comparison, you can set the sun path in your SketchUp via the model info and go to set manual location. And then you can type in country location, and then you can just Google the longitude and latitude and then copy paste it in. And then SketchUp will do that for you. You can go more in depth on that later. So what I'm worried about with this scanning 45 cm eaves was the shading inside. But turns out if you just follow this like zero point 0.9, 1.2, and zero point 0.6 na setup for your rooms, the shading isn't really so much of a problem. Like this is June, this is our summer, and 9 a.m. North is this way, the green axis. Like if you directly align your room north, you should be fine. This is the only sort of what do you call this? Excess sun that's going into your room. My actual room is angled a bit like 15 degrees from what do you call this? East going north. So it looks like this. Like in plan, it looks like this. So I'll show you my house over here. So my house is like this. It's angled a bit like 15-ish. So that's what I tried to copy with SketchUp. Actually, it's a bit more angled. So like maybe like that. Oh, I didn't include the wall. Hang on. So let me make that part of the group. Make group. Okay. So something like this will be very useful for determining your about like that. how much sun is actually going into your building. And you can also do this with Revit. But I feel like most people do this after the building has been designed, not using it when you're designing the buildings. So notice again, with this setup, 1.2 meter height for the windows at about zero point 0.9 from the ground, not much sun is coming in. And just to show you that it's working, I also tried this on another location in Sydney. At the same time, this is what the sun looks like. This is how much light is coming into the room. So at zero point 0.9 window height from the ground with the 1.2 height window, this is like a lot more sun is coming into the room at the same time. So June around 9 a.m. So there's a lot more sun coming into Sydney compared to um, Cebu. And the reason for that is you see the angle of the shadow. The sun is a bit higher compared to Sydney. The sun is really down here. And just a quick sort of reference how you can measure the sun, like in our geisma.com, I was hoping somebody would like mention this in sustainable design, because really the sun is such a free resource that we're not using. This is why I'm like really promoting the what we call this, solar panels. Notice it tells you here, for example, the December solstice. December solstice is, it doesn't tell you the date exactly. I think you can Google it. But at 12 o'clock during the December solstice, you can see on the screen, the azimuth is 187 degrees and the elevation is 55 degrees. Now, what does that mean? Simply put, there's a drawing here. The azimuth is the angle from north, and then the elevation is the angle of the elevation. So if you quickly, I'll just draw this in paint. How do you like manually do this? If you have like your north is there, so your go back to geisma.com. If your azimuth is 187 degrees, so you go, let me go to paint. So that's 90 degrees. So about here, 187. So this is 180. So it's about here. So I'll do that 187 from north. So if you do that in like isometric, north is here, and you're going 187 like that. And then the elevation is, let me go back again. The elevation is 55 degrees. So 90 degrees is like straight up. So 55 is a little bit less than 90 degrees. So something like that. So this is 187 over here. And then the sort of the vertical angle is 55 degrees. So if you go to SketchUp, you can kind of see that 55 degrees, but it's different because we're looking at what do you call this, 9 a.m. Let me move that to noon. So you can see almost wala na siya. So 45, my drawing is a bit off. This looks more like 30 degrees because like 45 is higher. So maybe it should look more like that on 55. And you can see your person would be here. So looking at the SketchUp, you can say that's accurate. So at 55 degrees, it's almost kanang 55-degree elevation with an azimuth of 187. It's almost on top of your building. And then let's see the same situation in Sydney. If you move the noon to noon, it's still like a bit on top, but there's still more sun coming in. So where is that PDF, Colleen? Did you send it?
Yes, sir. Nasa comment.
Ano,
Sa
okay.
comment. Yeah. So first,
Send this one.
no, that's sir.
Oh, wait. The first one. Okay.
Yeah. So and the second one is the PDF. The first one is the
Also,
site
napo
for
diri
experience.
si Kuan.
Yeah.
From Sir Rowell.
Yeah.
Sun angle 2, sun position, overhang analysis. Oh, these are all here. Thank you, sir. I'm just using SketchUp. So calculation of monthly heat gain, visualization of louvered system. So like we'll try these out. Overhang analysis. Let's say what's easy to do. Basics, latitude from the equator, measurement scale. Let's see here. Let's try inputting Cebu City. Cebu City coordinates. Let's see. I'm not really sure which one is longitude and latitude. So I'll just double make sure over here. And system. It's simple decimal standard. It's 10.31 degrees latitude. Let me try this out. Do. Where did it go? Here. 60 equator south. 10.31 degrees north. Okay. Let's see. 10.31. Since they say 10, let's say June, middle of June. Let's say 12. Measurement scale is, I'm not sure what this is. 10, 25, 120. This is the length of the window? I don't know what that is.
You
Window.
can try the second link, Roy.
Ang second length. Okay.
The one I gave you.
Okay. Wait, I'll look at this one. This is designed for Philippines, but
download,
also
sir.
applicable in many parts of the Pacific.
Ito, no?
Okay.
Download, sir.
Okay, no. Anyway, this is a very long-winded way of saying that I'm not so sure about the where's that roof eave thing? Roof eave. Do. Okay, 45 cm max. So let's say we have the 45 cm roof eave here sa Cebu. I'm gonna pop out. I wish I made this like a component. Oh well. Let's say we have 0.15 here. And then let's pop it out 45. See what happens. Oh, no more sun coming in. And then let's say on this end, definitely mawa na yun ang sun. 0.45. Oops, sorry. Just wanted to check it. So it seems to check out. 0.45 is really all we need. So sayop de akong una na from college pa na we need longer eaves. You actually don't need that much eaves DI. So let's try changing it to like the afternoon at 3 p.m. Oh, it's going to the other side. Hang on. 0.15, 0.55, and then try it on this end. Down, 0.15, and pushing it out, 0.45. Okay, let's see, not much difference here. Let's see, I'll push this back in. Push this back in. The shade doesn't seem to change. Push this back out. 0.45. Not so much afternoon sun gamayang effect. We like increase that to, let's say, another 1 meter. Then definitely mo na siya. I think it's a morning, not so much a problem. It's the afternoon that's a problem with the 0.45. Let's change it to morning, 9 a.m. There's still some light coming in. Whether like you want it to come in completely or not, that's really up to you. But according to this research, the SWD 45 will be good to protect the wall from rain, but not so much the sun. And then you have like use more nails at roof edges, and it seems like the best pitch for the roof, the angle, is 30 degrees. The strongest is really multiple roof slopes reduce the risk of your roof being pulled apart. I think for the most part, we have a lot of shed type roofs, motudagan na damage o that. And gable side roof is also very popular in the Philippines. Okay, so just with this, you can see the morning sun is not so much a problem in the Philippines, Cebu. It's really the afternoon sun that's like manages to sneak in like way more compared to the morning sun. And the 0.45 is not really coming up. I don't think this is such a problem. And then let's discuss further about the impact of your sort of facade. If you want a full glass facade, if your height is 2.7, total height here is 2.7, that's 0.9 plus 1.2 plus 0.6. Should be 2.7, let me double check. That is 2.7. So let's say you want to, whoops. Let's say you want to make it floor to ceiling imong opening. How much sun is coming in? You got that, and you got that. So I think almost the 0.9 is actually blocking a lot of sun. So if your sort of bus terminal is going to be like a high ceiling thing, you're definitely going to be expecting a lot of sun to come in. So this is just 2.7. Let's say you make it 3. Let's say you make one side 3. Okay, maybe like 2-story now. I'll just move it up here. And I'll just use this as a reference point. From here, another 3. And then you're going to do that. Let's say you have like a floor above it, not so much a problem, but what happens when you make it like a high ceiling, like no floor above it? So even if you just move it like, let's say, just like that, or like maybe, let's just say high ceiling and get all throughout, na white floors at taas. So your ground floor will be totally exposed sa sun. So this will mean that you might want to do your like double facade system, pero again, that might be a bit too bulky and too expensive. So what does that mean for you? What the heck, where is this coming from? It's attached here for some reason. Okay. What does that mean for your tropical design and your like sustainable design of your building is that if you're going to do something like this with a high ceiling, you're going to need a lot more air conditioning and your building is going to be it's going to get hot very fast. So is it really sustainable to employ a double facade na what they call this, na feature instead of just not having the like high ceiling in the first place? Like with this, you get more space, you get more usable space, and then you're also reducing the amount of sun coming into your building. So I guess my message is, don't just add technology for the sake of adding technology. Like really make sure that your building or your design makes sense. And we'll be looking at this sa bus terminal ninyo. So let me just, yeah. So you can do this with SketchUp. You can do this with your Revit, I think, if you do your massing first. And then this will lead into our schematic designs. Now, we have 2 weeks for this. If we double check, just make sure everything is double checked. April 20 is the deadline for our schematic design. That's about Holy Week. I'm sure some of you won't be working from Wednesday, Thursday, and Friday. So maybe we'll start Monday, Tuesday, and then skipping those 3 days. Monday, Tuesday, Wednesday, Thursday, Monday, Tuesday, Wednesday. So about like 5 days. But I think you can sneak in some work during Holy Week. I know I will be too. So for our schematic design, we'll be doing the bubble diagrams, but at the same time, you'll also be inserting your own concept. Like what do you want your bus terminal to be? So do you want, of course, everyone wants it to be sustainable. So if you design your building in a way that it's taking in too much sun, or like you're employing technologies that are a bit more sort of superficial, that will count as a negative on your grade. So just simple things like this, I want you guys to be aware of, because really it impacts your like sustainability a lot. Okay. So on other things besides sustainability, I think that was a good presentation. Let me check my timer. Oh, I closed my timer, but was like didn't use up the full 15 minutes. So I think it was about like 10 minutes. Lou, Ciara had about 14 minutes. Escardo used the whole 15 minutes, and Teves only used like about like 7 minutes. So very good. Okay, some other things on bus terminal design. I'll put this in another video.